And then you'd say, oh, it must rain every day.
So you can make that general conclusion because you follow or because you see that specific pattern or you see the
Yeah.
yeah.
Yeah. And actually sports are even better example of this. Um, I don't know how much you think about this stuff, and I don't want to mess you up when you play sports, but hopefully you can, like, if you're coming to the plate to bat and the first pitch is a fastball, and then the second pitch is a fastball, and the third pitch is a fastball. Okay. Well, we might believe that the pitcher is a fastball pitcher. Okay.
Right.
But but that's not really how this works because we know that he'll eventually throw a changeup or something. But
Mhm.
let's take it by batter. Batter number one gets a first pitch fastball. Batter number two, second pitch, or I'm sorry, gets a first pitch fastball. Batter number three gets a first pitch fastball. What's the general conclusion that you can make if
That
you're a batter that's
batter four is probably going to see a fastball first pitch.
right? Or then he always throws a fastball on the first pitch.
Right. That's interesting
But
that you like. Well, this is a little off topic. I just wanted to say it's interesting that you said. I wonder if you ever think about it this way because that's totally like you try to pick up on stuff like that. Just you try to see or you try to find that pattern that they're so if they're going to throw a first pitch fastball, then you can try to jump on that. It'll give you a big advantage.
and if you're
Yeah.
watching football, it's the same idea. Do they run on first down?
Mhm.
Do they always set up in a certain formation on first down?
Right.
You try to draw conclusions
Mhm.
from specific observations, specific to general. Okay. Now, going the other direction, general to specific, it usually starts with a theorem or a law in the most general sense. Okay. And I think the one your class often uses like the law of gravity. But it will say in the thing like this is a well-known law, like we believe this to be true. It must be true. There is a law. And you're supposed to then be like, okay, I'm starting out with something very general and applying it to a specific situation. So the law of gravity, right? Whatever goes up must come down. Okay. And then it'll say you throw a football up. What will happen? Well, you expect it to come down. So you're using this general theorem law thing that we accept to be true. Something you accept to be true, and then you use it in a simple example, like that you have in your own life. So we
For
can apply it. Sorry, go ahead. Go ahead.
no, you go, you go. I didn't
Well,
talk.
like the example you'll get in your classroom will probably be like a well-known thing, like law of gravity, or I don't know, something that we accept to be true. If there's clouds in the sky, it's probably going to rain. But this applies to sports too. Like I'm trying to think um, of a team. Okay, so uh, a few years ago, the Houston Rockets, and I don't know if it's still true, they set a record for like most threes in a season.
Right. That was like was it the 2013, 2014 season?
Yeah, it
Yeah,
was
I feel like it was
fairly,
around there. I
fairly
remember that.
recent. And
Hmm.
I mean they were like averaging like 30 or 40. I mean, they're just throwing up threes. I mean, and they didn't make like one three in their playoff series loss against Golden State
Yeah.
there and one of the game six. It was really amazing. Like they didn't make one three. It's really or they didn't make one until the end of the game or something. But like it's not quite a generalization, but you could say like that team was like generally they're going to throw up threes. So on any given night, you would expect them to put up, 33-point attempts or whatever it was.
Hmm.
Okay. And so we're going from the general, like generally they do this to that specific night. They're likely going to do that. And this
Right.
isn't as good as the laws, but that is the idea. Good.
No, I was just saying or trying to show that I understand
Okay.
yeah, that pattern.
Um, there are teams in football that run the triple option. Do you know about the triple option?
No, is that a offensive?
Yes, it's
Yeah.
run or it's like I don't know exactly the order, but it's like uh running back run uh I'm sorry, maybe it's fullback, maybe it's fullback. Yeah, I think it's like fullback run, running back run, QB run, something like that. So the quarterback takes the snap and either he hands it off to the running back, or there's another or the fullback, he either gives to the fullback, or he comes around, or he pitches it to this guy. So it's the triple option. He either gives it to the first guy, then or the quarterback fakes it, runs this way, and then the running back, he can pitch it to the running back. Triple
Right.
option, three options. Okay. This used to be called the wishbone. It used to be a really, if you watch Nebraska from the mid, I don't know, the mid 70s to the early 90s, it wasn't sexy, but it was really effective.
Mhm.
Okay. Um, so you knew this going into the game. Like you knew that this was what they were going to do. They were going to run, run, run. And you still see like teams like Army and occasionally some smaller schools do this. Um, run the triple option. Navy does that. Navy doesn't pass much. So you like know this. This is like accepted to be true. Okay. Like there's no question that a team's a running team. So when you get to an individual game, you expect them to run the ball. So if you're prepping all week for that team, you're gonna expect them to be running the ball. And that's
Right.
the general to the specific.
I see.
Okay. So that's like all you need, like you just need to remember this. Like inductive is specific to general, general to specific, and then you'll have it. And you, like I said, you get one question on your test where they give you a scenario. I don't know which one it is because I don't remember. I don't ever see the tests because they
Mhm.
hide them.
How do you
That's
just a random question? How do you see or do you know them for like the different districts, or are you just pretty like
I help a lot of
comfortable?
I have
You
a
have a
lot of
lot of
kids from your
background knowledge.
yeah, I help a lot of kids from your school.
Mhm.
But and I just remember stuff. I don't really
Yeah.
forget things, which isn't good in certain situations. Um, but it's really to help you guys because like they don't change them up and they should. So uh yeah, so here we go. We're gonna look at some examples here.
All right. Sounds good.
And what you have to decide when you're looking at this is are they making a specific observation or are they giving a general theory? That's kind of your fork in the road here. All right. Each time your mom goes to the store, she buys milk. So the next time your mom goes to the store, she will buy milk. All right, let me go back and grab these so you can decide which one you think it is.
Inductive.
Okay, because it's a specific observation.
Mhm.
Going to the store for milk. Okay. Do you think you do this in your life? Do you think you'd use inductive reasoning without even knowing you're using inductive reasoning?
Yeah, for sure. I
Yeah, I
think. Yeah.
think we all do. So when people say they never use math, you actually could say, yeah, you do. But I then what they mean is like, I never solve equations. Like, you're right, you never solve equations, but you do use inductive reasoning all the time,
Mhm.
all the time. Okay. Rational numbers can be written as fractions. Irrational numbers cannot be written as fractions. So 1/2 is a rational number. Okay. What do you think? Is it a
Deductive.
specific? It is you said inductive? What is the
No, I said
specific
deductive.
observation? Oh,
I said
deductive. Yes. Yes, it
yeah.
is. It's this one. Because it's starting out with a like definition. That's
Right.
another one, not just a law, it's a definition, a law, a theorem, something like that. And I'm trying to remember here because I've seen the tests. I think your school uses kind of a weird one. Let it isn't necessarily like accepted as true, but you like you have to accept it as true
Mhm.
as a law. Okay. All men are mortal. Is that true? I don't know.
No,
Different class. Mozart is a
Mozart is
man.
a man, so Mozart is
Mozart,
mortal.
is it starting out with a specific observation or a general, sort of a general theorem statement? Is this specific or general?
It's pretty specific. It's saying that all
But
men
it's
are
saying
mortal. Oh,
all.
okay, then yeah,
It's
it's
not
not a
saying
certain category.
it's not saying Mateo is mortal.
Yeah.
That would be specific.
So this is deductive.
Yeah. All right. So learned behaviors come from inductive reasoning. And this is the example of that. So I'm giving away what it is, but you can see, go ahead and read this, or I'll read it out later. Each time you clean your room, you're allowed to go out with your friends. So the next time you clean your room, you'll be allowed to go out with your friends. This is inductive
Mhm.
because it's a specific thing. You clean your room. Like, doesn't matter if, you know, like it could be different for another kid, right? Some kids clean their room because they like it, believe it or not. I don't know where you stand on that. Like, I like cleaning. For me, it's therapeutic. You get your mind actually gets cleared up usually too.
Yeah.
Um, but for some people, uh, you know, it's the whole like positive reinforcement. Have you heard of that? Positive
Yeah.
reinforcement and negative reinforcement.
Mhm.
Yeah. So this is a positive reinforcement. You clean your room, you can go out with your friends. You don't clean your room,
Can't-
you can't go out with your friends.
Right.
So believe it or not, there's so much overlap here in real life. We are, and you can disagree with this, but this is backed by books and other things. We are driven by two things, okay? Fear and rewards.
Mhm.
You go check this out if you don't believe me. Um, it is better to be driven by rewards. Way better. Let me talk about fear real quick. So you could become you could become the most wealthy person in the world, okay? But if you're driven by fear, you'll still be living in uh like on the floor, live on the floor. You won't want to have furniture. You won't want to drive a nice car because you're worried about losing all your money. That's the risk of living by fear, is you think you can never escape whatever situation you're in. Problem with rewards is if the rewards don't get big enough, you keep like chasing and chasing and you're never satisfied. So there's somewhere in the middle that's, a little better, but this generally is what motivates us to do anything. Like, I want to stay eligible. That's fear. I want to play in the games because I love baseball. That's rewards. And you want to make sure you're doing it for the right reason. So and the reason I bring that up is a lot of the inductive reasoning leads you to either one of these paths, right? Like, I clean my room so I can go out. That's a reward. I clean my room so my parents don't yell at me. That's a fear. All right, that's a side point. Okay. Next thing we're gonna work on are algebraic proofs.
Okay.
Unless you have any more questions on this.
No, no, no. Yeah.
Okay. So, you guys talked a little bit about this in class. It looked like you got like a little worksheet thing. Um, oh, do we need to do these problems? Are they
Number
for homework?
1, 2, 3, 4, 5.
Yeah. Have you done them or are
Uh,
they coming
I
to?
have those.
You've done them or we need to do them?
No, I got them down.
You got them done. How about the 3 and 4 from the table below?
3 and 4, I also have. Those
Okay.
were those were the homeworks for the weekend, but we like we learned our class is only like 14 people, which I actually think is helping me because our teacher isn't like the best teacher to the whole class, but she comes around and when she explains it to you, it actually makes sense. So we get a lot of in-time classwork, basically, is what I'm saying. We
Great.
try to get our
That's
work
great.
done. So yeah,
That's something to consider as move forward. You may find you have a certain preference for class size like
yeah,
that. Okay. Let me pull up some algebraic proofs here. Okay. This is from another student, but it really applies to what you're doing. Okay. So most students actually like algebraic proofs. You're learning proofs because you're going to do real proofs later in this course. And this is supposed to be a fairly helpful introduction to that, which I agree. I kind of think it is a pretty good introduction. So the first statement and reason in your proof is always a given. Have you seen this before, S and R proofs?
Yeah,
Okay.
yeah.
You always rewrite the first line and it's always given because it is given. So you don't have to think much about that. The first
Mhm.
line is always the given. Now, what's missing is there's almost like this like other like and you maybe want to do this like on another sheet of paper. There's almost this like scratch work where you actually perform the step. So what you'll notice is that each of these lines here is the result of the step. Okay, and you'll see what I mean in a moment here.
Mhm.
The first one, if you like, if I were to write a 1.5 step, here's the 1.5 step. Okay, 2 times a plus 2 times 1 equals -6. That's the 1.5 step.
Oh,
But then 2 times a is really 2a, 2 times 1 is 2. So like, and this one's not very difficult, but you may find that you have to come off to the side and do a scratch work step. Now, what are you actually doing? Like, what are you doing with this 2? What's the math word?
the two is, oh, that's not distributing, but you're carrying it over.
Yes,
You're,
yes,
oh, that
yes,
is? Okay, yeah.
yes, it is. So this is way more like vocabulary. Um, you're expected to give a certain word or words. This is actually the distributive property of multiplication. Now, some teachers are really specific. They're like, I want correct spelling. I want you to say of multiplication. I want you to write it out in cursive, make you capitalize the first letter. Like, I don't know how extreme your teacher will be. Like, because I don't care. Like, this is ridiculous that you have to handwrite something like this. It should be typed anyway, but you need to find out from your teacher if you're going to have to handwrite it or the full thing of multiplication, or if you can just put the multiplication, or if you can say, dist prop of x, like it's very formal in some courses. Like if your teacher were say, 80, they would be like, no, we're gonna write the full thing out here because that's how they learned it. So just ask or find that out. Now there's a full list of properties. Now, do you have those full list of algebraic properties?
Me,
Probably not, because I don't even know if they put them out there.
no, I don't think so because,
So
yeah, no.
there's the um, multiplication property, the addition property, there's a bunch of these things. And like it's kind of like what you're doing. So we'll maybe say here. So step two, so the step 2.5, so 2.5 is you are subtracting 2 from both sides. That's the step 2.5. Okay. And the result is step 3, but it's like, what did you do to go from 2 to 3? Well, you subtracted 2 from both sides. So that's called the subtraction property of equality.
Mhm.
And that's what I was asking. Like, do you think your teacher's going to expect you to know all of those? Uh,
Well,
like what, the-
I don't, maybe like later on in the future, but we haven't even, like, we've just been doing the solving. We haven't really been putting in the definitions, you know what I mean? Or we don't really,
okay.
yeah.
So the whole point of the problems you sent is that not to solve them, like you already know how to solve them. It's to explain each step
Right.
that you have. Step 3.5 here is 2a equals -8, divide by 2, divide by 2. So a equals -4. What is the math operation that we did there? The division property of equality. Any questions, thoughts on that?
No, I got it.
Okay. All right. So here's one for you to try. That's they're never going to be exactly the same. That's the problem with proofs. Like it's not like an algebra one where we just give you a lot of problems that are the same. It's not like midpoint or median or altitude. Like I can make those up. These are going to be very specific. Like so give this one a try. Um, write down, the 4 reasons that you see here. Let me know what you come up with when you're all done.
What's it? I'm trying to think of the actual like definite. Is the first one distributing, or is when you're making two sides equal? What's that? I know there's an
Well, t-
actual
tell me what your step 1.5 is. What are you actually doing to solve the equation?
step 1.5. They subtracted 3x from the right side.
That's right. So that's the subtraction property of equality.
Oh, okay. That's what it's called. Okay, so
So
subtraction.
it's typically less complicated than you think.
And you think,
You just call it whatever it is that you're doing.
okay. So then the 2.5 addition, I'm not sure what it'd be fully called, but you're moving the negative 18, you're adding 18
Well,
to the
there,
other
well, you
side.
just said it. You just said it. What are you doing? You're adding 18. That's the
Additional
addition property
addition property.
of equality.
And then 3.5, you're doing 2x, so that's a divisional property of
Yeah.
equality.
So just to be clear, like when I was saying step 1.5 and 2.5 and 3.5, those aren't associated with the reasons. The reasons are given, subtraction, property of equality, okay, addition, property of equality, and then division, property of equality. Those steps that I was referring to are just for you. They're kind of off to the side if you're not sure what you're actually doing.
Mhm.
And like it's almost better to take the original statement and solve it, showing the work. Like you just said, like, yeah, I'm gonna subtract 3x from both sides. Oh, what did I do there? Oh, I subtracted. That's subtraction property of equality. Okay. Oh, what am I doing here? Oh, I'm adding. That's the addition property of equality. These are just like scratch work steps. Your teacher doesn't want to see this. Well, they do, but they don't. It's not part of your answer. It's your show work. They don't want to see that. Is that clear?
Yeah,
Okay. All right. Let me give you another one to try here. Take your time on this. I'm going to step away for 30 seconds,
got it.
but I'll be right back to check in with you. That's a shot though, please. All right, what do you think here? Or if you need more time, that's fine too.
Yeah, I need a little more time for the first
Okay.
one, distributive.
Nope. First one is given.
Oh,
First
given.
one is always given. So
Okay,
the reason for step two is what you just said. It is distributive. So yeah, it's always it's like what did you do to go to that line? Well, you
right.
distributed. All right, yeah, take your time here. Let me know when you got it.
And then would the next one be on 3 or because I don't, oh, I guess the minus, where is that minus 3n going?
So like I said, probably a good idea to like solve it off to the side
Oh,
and then
wait,
look for your line. Like you're combining these
combining like
two.
terms. Yeah.
Yeah. So sometimes that's just called simplify. Sometimes it's called combining like terms. It depends on the teacher, class, things like that.
Yeah. So simplifying got that. Okay. Then
Yeah, keep going. Keep going. Yeah.
subtraction distributive property or what's the full thing
Subtraction.
called?
It's
Subtraction.
it's it's the math operation. So it's add, subtract, multiply, divide, property of equality. And that just means you're allowed to do the same thing to one side as the other.
Mhm. And then the ends or the variables. So I think that's another subtraction. Or
Well, what are you doing with this?
you're
Oh, I'm sorry.
subtracting twelve.
Yes. You're subtracting 12 then. Yes. That's correct.
And then 5n equals minus 55. That'd be division dividing by minus or 5n. And then for 6, what do you do once you have it right there?
Again, like it's what are you doing to go from 5 to 6? That's what goes here.
Oh, the division.
Yes. So
Yeah.
that's division.
Okay.
Division, property of equality. For 4, it's what are you doing to go from 3 to 4? You mentioned that you're subtracting 28, so it's the subtraction property of equality. To go from 4 to 5, you're subtracting 12n. So it's okay to have the same step 2 times in a row. That's okay.
Got it.
All right, let me look for some more algebraic proofs for us to work on. I thought I had one more, but I don't. Yeah, so the way that you're going to get a problem on your test or quiz is it's going to look more like this, where um, and the teacher's trying to this is kind of what I was trying to show you. So we'll do an example like this. So it says that on the left here, it says solve the following equation, justify each step as you solve it. And then number 2, it's like, oh, rewrite it so it is formal. That's where you're just showing the end result. So on the left here, the first thing you would do is you would distribute this in. It would be 8x minus 3 minus 8 equals 4x plus 2x. Okay. And that's the distributive property of equality. Then the next thing you're doing is you're combining these two. So you end up getting 8x minus 11 equals that's a 4 there. 4 plus 2x, like that. And that's just simplifying. Okay. Now we're going to move the 2x over. We're going to subtract 2x from both sides. So this becomes 6x minus 11 equals 4. And that's the subtraction property of equality. Now, so far, here are the lines that you're going to include in your real proof. This one, that's given. This one, and this one. This is what I meant by you have sort of scratch work off to the side. Next thing you're gonna do is add 11, 6x equals 15. That's the addition property of equality. Then you're going to divide by 6, x equals And then you reduce your 3 over 2, and that's the division property of equality. So again, like, here's what you would actually include in your proof: this line and this line. So you exclude these steps, okay, that are not highlighted. So you would write given. That's what it means by formal. It's like without all the extra stuff. 8x minus 3 minus 8 equals 4 plus 2x. Distributive property equality. 6x minus 11 equals 4. That's the subtraction property of equality. 6x plus 15 is the addition property of equality. 6x equals 15. X equals 3 halves is the division property of equality. So the idea is that your teacher's asking you to, like, this is what they want to see, and then this is the work that you have to sort of show off to the side.
Got it.
All right. So we're not quite there. We're going to continue to work on some of these, but let me throw a few more in front of you to work on. So let's call these this A, B, C, and D. If you could take a moment to solve this, fill in those, and let me know what you come up with.
X equals 10.
Yeah, we already
Oh,
know the answer. Yeah, we already know
oh,
the
you're just
answer.
asking for B?
Well, no, this is asking for like the statements, like what goes here, what goes
Oh,
here, what
okay.
goes here,
Well,
what goes
okay, I
here.
have those statements.
Yeah, so tell me what goes in number one.
The given is already there. 5x minus 18 equals 3x plus 2.
Good.
And
What's
then
the reason over here for
B is additional property of
addition? Yeah,
the
it's
8
addition
minus.
property. Yeah. So see how
And
it just
then,
says subtraction property, addition
yeah,
property, like maybe that's okay. All right,
yeah.
3.
And then 3 is 2x equals 20.
Agreed. Keep going.
X equals 10.
Good. Okay, so this is not about the answer. Like the answer is even given. Like
Mhm. I
you're
didn't
not
even,
like you're not given any credit for solving. You're given credit for, can you put the right things in there? It's like a puzzle. You know what the puzzle looks like. You get credit if you can do the puzzle
mhm.
from start to finish. Okay, let's try another one here. Doing real well on these. All right, so I'll do the same thing here. I'll just label, A, B, C, and D. You can take a look at that.
For B, well, what I'm trying to do is, so it's 2x minus 6 over 3. Can't the minus 6 and the 3 be crossed out and be minus 2 on top over 1 on bottom?
That is, that's not allowed, but remember, it's always given, always given. So
Oh, right. B's again. Okay.
what you're missing is there's implied parentheses here.
Oh,
Okay. They're telling you what to do next. They're saying multiply. What could you multiply both sides by?
2x.
How do you undo this division?
Oh, you have to flip it.
You multiply by 3.
Oh,
So this is your side work. This is your scratch work. And what's the result of this? Well, it's 2x minus 6 equals 24. That's what goes there.
right. Okay. And then D would be divisional property.
Now you're not graded on like everything or nothing. So the fact that you can do some of it gets you partial credit. Uh, yeah, you just you want to try your best to get uh, as much as you can. Okay, now what I don't know here for this problem is if you need to fill them all in. So I'm not sure. Given then that and then that. I don't think you need all of them. I think you can leave out the last one, but this one requires you to put all the statements and the reasons in.
Okay.
And that's kind of what you'll have on the test there. So take a look at that, please.
All right. I got it.
What is your first statement?
Given.
No, that's the reason.
Oh,
Statement.
my bad.
It's okay.
6x minus 4 equals 3x plus 8.
It's very weird. Accountants love this stuff because it's very formal. It's very like, it's the way we have to do it. Some lawyers, if they're very like the law is the law, like they like this stuff too. It depends on, how attuned you are to like specifics. Okay. What's the next statement?
6x equals 3x plus 12.
Yes. And how did you do that? Which is your reason?
Addition. Additional
Addition,
property.
addition property. Yeah. Okay. All right. What's the next one?
The next
What's the
one
next?
is subtraction. So it's 3x equals 12.
Good. And then
And
your
then
final
the
one here.
final one is x equals 4 and division property, divisional
Very
property.
good. Very good. Very good. Okay. Now, basically out of time here, but let me just show you real quick. Another way that you could do this proof, which is why these are, tough to grade, is instead of adding 4 first, like you did, you could move the 3x. So you could get 3x minus 4 equals 8, subtraction. Then you could add 3x equals 12. See how the two steps are just out of order, different
Yeah.
order, but you get the same result and they're both correct. So there's actually more than one way to do a proof. which a lot of people like that are in this world. Pure mathematicians love this because, it's like an art. It's like an art form. You draw something, everyone's got a different interpretation of it.
Right.
All right. Uh, we are heading in the direction of more proofs. So just keep that in mind. Like you're going to be doing this for a while. It does end at sort of the middle, right before finals.